Hi there, welcome to Hoya Robotics. This is a tutorial on rapid prototyping. This is the first in a series of videos that we're going to be doing to go over rapid prototyping. And my name is Ian McTavish. I'm the lead mentor for Hoya Robotics. So basically, we're going to take a challenge and we're going to use the challenge to figure out how to do some rapid prototyping. So this is Ontario Skills for this year, and the goal is to take the trees from the far end there, and I'm just going to put a pointer. So here's the trees at the far end, whoops, and move them over to the river. So from that's point A and that goes to point B. And our strategy is we're going to have a robot that extends and has a conveyor belt. So we'll have some type of intake mechanism and we'll do a conveyor belt to the other side. So the goal with this is we're just going to focus on the conveyor belt system. We've got other students that are working on prototypes for the intake, and that's the key thing, is figure out what our strategy is, and based on our strategy, start coming up with some prototype ideas that we can test. So the whole point of rapid prototyping is we want to be able to quickly test something. Is this concept worth pursuing? And just as importantly, is it a waste of time? We don't want to spend time on something that's not going to work. So if we can come up with a way to test an idea and see if it will work or not work, that's really important. The lessons that we learn we use them to develop our next prototype. So we might have an idea that we're going to try and find it works, but we need to do something different. And the whole point is it's an iterative process. We do one thing and that gives us an idea, and we do another thing, etc. The other goal is that we want to use materials we already have. We want to reduce our costs and we want to reduce waiting. Time is really important. So the more prototypes we can do, the more secure we can be in that this is a good idea. So it's really important to get that idea down fast. So this is the conveyor system that we're looking at. Will Zed was looking at this and he thinks it's a great idea, and he came up with all kinds of good reasons. So we're going to pursue this and make our own prototype. And the idea here is that it's a 3D printed tread with a flexible material, which we have, 3D printed pulley, which we can make as well. Now, instead of making this, we're going to do a test that we're going to use with materials that we already have, so we don't have to spend money on 3D printing and spend time. We've already got some stuff we're going to try. So these are the materials that we're going to be using, and I'm just going to explain them because we use them for prototyping a lot. So I'll quickly go over all of them. So the first thing are the belts. So we have two belts that we're going to be using. One is an HTD belt. This is a belt that we use in the Andy Mark kit of parts drivetrain every year. And so we've got quite a few from robots over the years, and we're just going to try using that as our conveyor. The other one is a really small belt. I bought a few of these and I try to buy a few every year. And the whole idea is that we can mount the motor very close to the shaft, so that we can transfer the power from the motor to turn the shaft, and that's the goal. We also are going to use these pulleys. Again, these are used on the drivetrain every year, so we have a bunch of them so that it's easy to reuse them. So we'll use these pulleys for the conveyor system. This is the motor that we're going to use. Basically, there's two motors that we try to use for prototyping. One is the 775 Pro seen here. And the reason I like using this one is we have all the connections. So we have a motor controller system that we can use. So we can just plug this in and turn the dial and get the motor spinning really fast. And the other thing is that there's a pulley already on it. So combine that with the belt and we can connect it really quickly. So that's the goal. And we have a few of them. We also do prototyping with the sim motors. They're slower. They've got a lot more torque, a lot more power. So that's what we're going to use. We need a pulley that will transfer the power from the motor over to the shaft. And so this is the pulley we'll use. And same thing, we're just using this for prototyping. We get a bunch of them, and so that we can test. Now, Obviously, our motor is going to be very fast. This will give it a little bit of a reduction in speed, but not a huge amount. But for prototyping, it's just the concepts that we're aiming for right now to see if that works. The other thing is that the hex shaft, we try to keep a bunch of hex shaft in stock. Typically we use steel, might need to sand it down a bit so that we can fit things smoothly. We try not to use aluminum other than for weight savings. We've found with long spans, so our intake last year, all the polycord that we had put a lot of pressure on over the 3-foot shaft that we were using. And so we found it's easier to use it out of steel so that there's no bending at all. Shaft colors. So for prototyping, these are great. Basically, you have a little set screw, and so you can put this on the hex and tighten up the set screw, and it locks things in place. We don't tend to we try not to use these in competition so that we don't run the risk of them coming loose and shifting position and stuff. We also like using spacers, and our goal this year is to 3D print a bunch of spacers so that we just have some in stock so we can quickly add an 1/8 of an inch spacer or a 1/4 inch or something to line things up. And bearings. Again, try to keep a bunch of these in stock. We use the bearings to be able to secure the shaft so that we can spin it freely. And the last thing is hardboard. We get this from Home Depot, 1/8 of an inch thick. It cuts really well on the laser cutter, nice and quick. We've also used 1/4 inch Baltic birch, and both are great for making prototypes. So comes some key geometry stuff. So first off, we've catted everything in terms of the game playing field so that we can see, okay, we have this positioning, and so the ramp position is 135 degrees, so we'll use that. And I'm just going to switch right now to here we are. And so we're going to just do a sketch on the right-hand playing field. So those of you that don't know CAD, please take the time to learn it so that you can, it will be really, really handy. And I'm just going to escape. So I mentioned this was 135 degrees, so I'm going to dimension that 135 degrees. And basically that, I'm going to undo that because I realized that my 135 degrees is from the vertical axis. So make sure I'm dealing with the right thing. So there's my axis. That's just great. The other thing with the geometry is the Spectrum Robot design sheet. There's a mechanical tab in there, and you can find the spreadsheet there. It's a Google Drive spreadsheet. And based on the mechanical tab, let me just move that out of the way, you can enter in the pulleys that you're using. So for our 5mm belts, this is the belt for the conveyor. We're using 42 teeth pulleys, and the belt is 131 teeth, so we can quickly calculate this. West Coast Products has a great belt calculator, but I found the Andy Mark kit of parts uses 131 teeth, which they don't include in the West Coast products. So I need to use this calculator to do it. And anybody interested in math, look at the formula. It's fascinating. The other belt was for the motor, and that's 2.077. So I'm going to use that information right now and switch on over here. You can see I've already entered it as variables. The variable tool is really handy because I can do that. So I am going to take my measurement tool, and I'm going to measure that line. And so this is going to be the conveyor belt line. And there we go. That's the size of that line. So that's really handy. At the end of each line, this is where my bearings are going to go. And the bearings are 1.125 inch in diameter. And the trick that I find, you'll notice that when I'm starting the circle, it's orange. I'm not explaining these concepts because I expect people to take the fundamentals in Onshape course and do the training. It makes it much easier. So there's also the equals here. So I'm just going to quickly use E as the shortcut, which allows me to make circles of equal size. So there is going to be my bearing. There's going to be my other bearing. I'm going to take another line and go from the center of this, and I'm just going to do a random spot, and the size of this, I just need to, the size of this one is going to be my motor belt. There we go. And I haven't set a dimension for that, but I'll need to do that. So the next thing is that I'm going to do a rectangle, and our laser cutter is 12 inches by 24 inches. So there we go. And basically, I'm going to take the geometry of this point, and so 6 inches was a little too much. So I'll just switch it to 4 inches. There we go. I want to make sure that both holes are going to be on that. And I'm going to add a distance. So, and I'm just playing with numbers here. 10 inches, what I'm trying to do is get it close to the end so that way, oops. There we go. That way we can position it and kind of test it up against the ramp and see if it works. So, okay, so that works. I've got that in position. I am going to need another hole here. And that hole is going to be where the motor goes. So there we go. I can extrude this. It is 1/8 of an inch. And I'm just going to take this sketch because I just realized something. I need a bit more room, and you'll understand why in a few moments. Okay, so here's my part. I've got my assembly, and I can insert that part, and I can fix it in place. So now that my part's in there and it's fixed in place, I can also go through, and I'm going to insert other documents. Now you can do public and search for MKCAD. I've added a local copy as well, and I really like using the local copy because it just loads that much faster. So that's the reason we use it. And there is the 775 motor configurable. I just realized 12-tooth G2 pulley and 775 connect. So we're just going to insert that motor. And somehow I added 2 motors there, so just delete one of them. Okay, so here's the one motor. And basically, I'm just going to mate that right there. And once it's mated in place, I'm just going to change that mate and I'm going to flip it around. So there we go. Now that I've flipped it around, what I can do is I am going to edit this part in context. And I'm going to go in and edit that sketch. And this is the reason that I edit that sketch is I can now go in and I've got the motor for reference. So that's probably a fair bit too big. I want to make sure that it fits the circle. There it does. So that's great. And I can right click on the parts for the motor. And these will add holes in my laser cutting, which is great. And these holes are really important. I think, can I select all of them? These holes are bent holes, so I always want to make sure to add them in. And the nice thing is with the laser cutter, it does a great job of cutting small, tiny holes. So it's easy for me to add these in. Sometimes I make them a little bit bigger so that we get lots of airflow. But it's an easy thing to do. And I'm not going to do all of them. I'll just do these two so that you can see the effect. And here's the second one. So obviously I need to keep doing this and do the other side as well and everything. But the key thing is that I've got a sketch now and I've got things positioned. And what I'm going to do is I'm going to take this information and I'm going to start doing more of the assembly. So I've got the motor in there. Well, what do I need? I'm going to need a shaft on the other side. Let's just go back to the assembly. So there's the motor. So I'm going to need a shaft on the other side. And then I'm going to need the pulley. And so I can check, is this pulley going to interfere with the motor? If that's the case, maybe I can flip the motor on the other side and attach the pulleys that way. I can start playing with all that geometry. I'm going to do that in another video. I don't want these to be too long, but basically I've started, and once I work out those details, and you'll see that in another video, then we'll be ready for laser cutting and we can quickly build our prototype. So I hope that's helpful. It gives you some information and some ideas on how to do rapid prototyping. And we're going to continue this series of tutorials later. Have a good day.